Flavio from SIPPulse. Enjoy.
The mic. Take one of the mic.
The man in the book.
One, two.
I have the survivability.
I'll be needing just a bit.
Just to make sure that they don't have
Power outage, yeah. Knock them out.
Right, it worked great from the other. Nice. I never tried this one. I always use it the direct easy.
Sure. Just turn on the mic.
Hello? One, two.
Enjoy.
Hello, good morning. Good. Almost there. The last presentation before lunch, so I'll try to be quick. Okay. SIP in the wild, how is to support real-life SIP operations? In the last 8 years, we were implementing a lot of platforms for SIP in Brazil, more than 200. So we have a bunch of customers, and one of the problems that we have is a lot of tech support. If you implement, today for this presentation is to show you what it's like to support a real-life SIP operation. So, my name is Flavio, CEO and owner of SIPPulse, co-author of Building Telephony Systems with OpenSIPS, for those who know. Well, in the first place, why bad signaling is relevant for the SIP operation. If you can't handle bad signaling, you won't be able to run a platform in real life, because there's a lot of issues with SIP in real world. Usually bad signaling causes disconnected calls, hanged calls, one-way audio or no audio at all, differences on billing, expensive and lengthy tech supports. There was one time, I think 2 years ago, that we were processing 100 support tickets per week in our tech support team. There are many platforms, many issues from different vendors and different clients. So we started trying to, hey, how can we handle this? How can we better handle this on the platform? Where you should expect problems. Usually you're going to have problems when you don't have a control. So when you don't have a control of the client, you can expect problems because you can have any type of client on your network. When you don't have control over the termination, you can have any termination, and it's funny, when you have a wholesale provider, it starts to inserting new terminations. For the laughs and the smiles, I can see that it's not a problem that happens only with us. A new termination till you get one really bad, and you start having issues, right? So that's the idea. The most exposed operations are the ones with high volume and no control of the client or network. The less exposed operations are the ones with medium volume when you have the control. So if you control the network and you control the clients, you're not supposed to have a lot of problems. But you don't control, if you don't have control of the clients or terminations, you can expect a lot of problems. Right, so that's the whole idea. The RFC is like the SIP heaven. All components from different vendors works perfectly. Sure. Networks are well dimensioned and reliable. This is the SIP heaven. But what we find in the field is more or less like a SIP hell, right? Incomplete implementations of SIP. Some clients do not support record routing. We have different interpretations of the RFC in race scenarios. We have protocol errors, substandard networks. Probably you don't have a customer that uses a 5-port gigabit internet to run 2,000 simultaneous calls. And timing issues also cause some issues on billing. So this is what we get in the real world. So to support this limbo, we have two approaches. Our first approach was fix at the source. So if you have a problem with the client, fix at the client. It's nice. I remember a support ticket, something like, hey, my ATA is not working. And the tech guy did a trace, hey, you have a problem with your ATA on your analog telephone network. Oh, that's great. What I should do? Replace it. Okay. 30 days later, I received a cancellation. Why a cancellation? Oh, I have 2,000 of these ATAs. I can't replace all of them. So we need to find a way to fix this, or to find a way to be more robust to support these types of clients, right? And when you say fix at the source, one thing that you hear a lot of times, it was working before with asterisk. Right? So it's not an easy answer. So our idea was to create a robust platform and fix when possible the problems. Early warn when you can't fix, and set clear expectation of what is possible, what is not possible. That's the approach we have. Main problems caused by bad signaling: disconnected calls, hanged calls, no audio or one-way audio, and differences on billing. So let's go one by one. The first one is disconnected calls. What causes disconnected calls? Usually the lack of the ACK is the main cause of the disconnected call. When you receive an invite to 100K and you don't receive an ACK, what usually happens? One of the clients will disconnect the call in 30 seconds. Right? Usually the endpoints will disconnect the call in 30 seconds. ACK out of dialogue is not a problem. You receive the ACK, but the to tag is wrong, or it's rare to see the call ID wrong, but the to tag is wrong. So you receive a 481, callback does not exist, and the call is disconnected too. RTP proxy timeout. Sometimes we have silence suppression, and you are monitoring the RTP to see if the RTP is okay or not, disconnect the call. And with silence suppression, it stops sending the RTP, and the RTP proxy sends a notification to disconnect the call. Disconnected by the interface. Sometimes you have a prepaid interface, there's no credit, and it disconnects. One interesting thing, and so this is the idea. Send an invite, receive a 200K. If you don't have an ACK, usually after 30 seconds, you receive a buy from one endpoint or the another, or both. There's a good tool on OpenSIPS on the newest versions. Not so new. I think since the 1.10 or 1.11. You have this. This is the DLG end reason. The DLG end reason is a variable that shows you from where the call was disconnected, from the upstream by, from the downstream by, lifetime timeout, MI termination if you prepaid system disconnected the call, peak timeout, or the RTP proxy timeout. So it can be a lot easier to troubleshoot disconnected calls if you save this variable on the CDR. You can actually save this variable on the by CDR and increase quickly the way you resolve this. So, common scenarios: calls disconnected in 30 seconds or less. Some real-world causes for disconnected calls. User agent server behind net with wrong contact. It happens when you have a gateway, there's an asterisk server behind that, and you don't have local net and local IP. They send the internal address, so all the ACKs goes into the wrong place. UAC does not support record routing. You send the 200OK with record route, the ACK comes with no routing header. This is fairly common. Wrong to tag on ACK. There are some customers, when you fail over from the first leg to the second leg, they send the ACK with the 2 tag from the first leg, right? There's actually a platform that is very does exactly this. The ACK will receive a 481 call like does not exist. So this is the dialer. I just washed the user agent to avoid anything, but it's an ACK and you don't have a hot header on the ACK. This call will be disconnected. It's a very popular dialer on our region. All the customers that have this specific dialer will have the problem with disconnected calls. Possible mitigation. In the book, we have this section to handle sequential requests. If it has 2 tag, and then we use the if lose route, and then we use the validate dialog and fix route dialog, right? In the book, we don't have this or match dialog. If you receive an ACK, and what the lose route function will return? An ACK without the route header. Does anyone know? It's a sequential request. I'm sending an ACK without a route header. It will return false or true, the lose route. The lose route.
Yes, true.
Huh? It will return false.
Yes.
Right? Because if you don't have the route header, it will not lose route. So you're not going to execute this. Right? But if you put an or match dialog, this ACK will match dialog. And this session will actually fix the ACKs with the route header. So fix when possible. Actually, it will not insert the route header because you don't need to insert it, but it will send to the right destination using the dialog information previously recorded. So we can fix a lot of problems, a lot of disconnected calls just with this small section. The second type of issue that is fairly common is hanged calls. So you have calls hanged on platform form, right? This affects call counting, and call counting is extremely important. Let's suppose I'm selling a plan that is unlimited, but I'm limiting to 1 simultaneous calls because I don't want this user to abuse my single line. And then I have a hanged call. So I have 1 simultaneous calls on the system. What's going to happen? The next call will not work. And after 2 hours, because hey, I still can call, and this will generate a support ticket. So hanged calls are terrible. It affects prepaid calls. You have a 24-hour call running on the system, decreasing credit. It affects postpaid billing. You have 24-hour calls on your billing. That's really bad. What causes the hanged calls? Main causes: missing buys with the wrong dialog identifiers, calling from tag to tag, and problems with the ACK also are the same the ones that cause problems with buy. So if you can't route an ACK, you probably won't route correctly with buy too, because buy is a sequential request in the same way ACK is. So that's a normal call. Buy 200K ACK, call buy at 200K, and this is hanged call. So it's a call that I didn't receive a buy, either I didn't receive a buy, either I received a buy with a wrong dialog information. There's 2 possibilities. Example. Let me give you an example. This is an answer from a server, from a termination. 200OK without a 2 tag. So if we receive a 200OK without a 2 tag, what's going to happen on the next ACK or buy? it will be sent without a to tag. You remember, sequential requests, the first thing we have, if has to tag. If it does not have to tag, it's not an indirect information. So this customer just put this termination on the system, and after a few days, he started to have all kinds of different issues, problems on billing, problems on hanging calls, problems wherever. And
Took him a few days.
huh?
It took him a few days.
A few days. It takes some time until discovery because you have to capture the packets. The problem with bad signaling is these tickets are lengthy. Sometimes it takes hours to figure out what's going on because you have to look at the signal. Hey, what's wrong with this packet? What's wrong with? It takes time. It takes a lot of time from the tech support. And the client is angry. This thing is not working. How do you mitigate the hanging calls? There are many ways. RTB proxy timeout is one way. In dialog ping, SIP session timers. For buys with wrong or no dialog, you can handle it on the OpenSIPS script sometimes. Because you can handle a buy. Say, I have a buy after the to tag, a buy without the to tag. You can say, hey, we have a different buy. What we are going to do with this buy? You can send to a queue and then process separately this buy, send to the management interface, and in the management interface send a command to disconnect this specific call. It's a way to do it. But the standard ways to work with hanged calls are RTB proxy timeout, something that you can use. You force the media to the RTB proxy, and when you don't have media anymore, you send a timeout notification to the SIP proxy. This is the standard way. Some people from wholesale do not like this because it uses a lot of media, a lot of gigabytes. So you can also use the in-dialog ping. In the dialog module for OpenSIPS, you can set the in-dialog ping. It sends an options to the phone, and the phone sends back a 200 OK. When the phone does not answer the options, it disconnects the phone. Right. So it's also a very good way to do it. In the newest versions, you don't need to use options. You can use green lights instead of options. In the newest versions, I believe 2 dot something. Right? In the older ones, you can't. The problem with options was there are many platforms and clients that do not answer options. Asterisk, as an example, you need to configure asterisk to answer options. It does not answer options by itself. If you're sending your buy to another soft switch, another proxy, you don't know what you're going to have on the other side, so you cannot use this. But now with reinvite, you can actually send this to keep the state of the phone. And there's the standard way called the SIP session timers, when the client sends a reinvite from time to time to keep the state. Actually, I don't like a lot the SIP session timers. It's too complicated and heavy compared to the in-dialog ping. With in-dialog ping, with the reinvite, it's much simpler and stable than SIP session timers. Okay. Next, difference in the number of CDRs and difference on the duration of the CDRs. These are another problems that we find a lot on real life. Difference on the number. This is a fairly common problem. You have client, provider, and provider's gateway. So you're receiving a call, and the call was sent to the provider's gateway. The provider sent back a 200 OK, but we had a network failure. Let's suppose we have 1,000 calls in progress, and the network fails. What's going to happen with those 200 OKs for the completed calls? This completed call will not go through the client, right? What's going to happen on the provider's gateway billing? This is a completed or not completed call? It's a completed call. And for the client, this is a completed call or not completed call? It's not completed. It's a 408. It's a timeout. So you're going to have 100. Let's suppose you have 1,000 calls in progress, and you completed 500 calls. you have 500 completed calls more on the provider's gateway than on the customer's. How do you fix this? There's no way to fix it. The only way to fix this is to have a good network, is to have a resilient network. Because and explain to the customers, hey, if you have a network failure in the middle of the operation, you have more CDRs on the providers than you have on their client. Right? The only way to solve this problem is to have a resilient network. If one part of the network fails, another replaces it, and you don't have a network failure. With network failures, you'll always have a difference in the number of CDRs from the providers to the clients. A single outage is responsible for having problems like this. Differences on timing. This is another one for signaling that's very interesting, is the session disconnection delay. What's the session disconnection delay? When you get a call, the duration of the call is from the 200 of the invite to the 200 of buy, right? It's per transaction. The duration of the call is per transaction, right? When you account the duration of the call on an OpenSIPS server is per transaction. You will go to the receival of the 200 OK for the duration. But sometimes your customer will say, hey, I have sent the invite, the 200 OK, and I have sent the buy. This is my time as a client for the duration of the call. In most cases, this is not a problem because you have a very small session disconnection delay in order of milliseconds or microseconds. So in microseconds, we are going to receive the 200 OK, and usually you don't have a lot of difference. But suppose that you have a session disconnection delay of 4 seconds. All calls on the provider, on the proxy, will have 4 more seconds than the billing on the client. If you have an asterisk server, they use the CDR by the request of the buy. It's the end of the call, not the 200 OK. And the OpenSIPS, you have the end of the dialog in the 200 OK. Right, so there's this difference. What we saw on this, there are some GSM gateways that sometimes takes 2, 3, 4, sometimes 5 seconds to disconnect the call. Right, and in these cases, what we are going to have on the billing, differences on the duration of the call. So if you can monitor the session disconnection delay on the system, you can monitor for terminations where you have a high STD and remove these terminations from your network. You won't have this problem, this differences on the EC. Okay. Time synchronism issues. This one is quite interesting. It took me a lot of time to figure out what was the problem. And let's suppose a call with a real duration of 200 milliseconds. Right? In the vendor clock, it started at 19:01:49, 900 milliseconds. And the clock stopped at 19:01:50, 100 milliseconds. And the customer clock started at 19:01:50, 100. And the clock in the customer stopped at 19:01:50, 300 milliseconds. Exactly the same duration. An interesting thing, many people say, how do you round your measurements? How do you round your call? We don't round the call, we round the measurements, actually. We are billing per second, we are not billing per microsecond. Most of the providers, most wholesale providers, they simply bill by second and not by millisecond. So you're not going to round the difference. You're going to truncate the measurement. So this call will have 1 second in the vendor and 0 seconds in the customer. explain this to a call center that has done 1 million calls with a delay of 3 seconds, and many of his calls are appearing with 4 seconds. They were not expecting to pay anything, and now they have a bill of 60,000 or 80,000. Some people respond that probably have exactly the same issue. There's absolutely nothing you can do here just to explain to the customer, hey, this is absolutely normal. We are billing per second. If you want to bill per microsecond, yes, you can. But you have to agree with your providers to bill in the same way, or you get a loss, right? So if you're going to round in your provider, you need to round the same way on your termination. Or you can bill. You can calculate the duration for the customer and the duration for the vendor. There's also this way. And the funny thing about this system is it's fair. Sometimes it's better for the billing, for the vendor, sometimes it's better for the customer. It's not an unfair system. It balances itself. But sometimes it's very hard to explain why there's a 1 second difference on the system in a call that has exactly the same duration. Why did I brought this here? Because I have explained this in the last year at least 6 or 7 times. It's perfectly normal. One-way audio or no audio at all. The main processes: incomplete non-traversals, firewalls, and application layer gateways. So usually, what you need to do to troubleshoot one-way audio or no audio is just to go to the invite in the 200 OK and check the connection addresses. In this case, we have 189.90.58.142, 10.8.129. It's fairly easy to understand why this call has no audio at all. We have an internal address connected to an external address. There's no connectivity between this address and the other address, right? Usually because of NAT traversal, right? Sometimes you have connectivity. You have network connectivity between both addresses, but you don't have, your firewall is blocking the ports between both addresses. So that's the second type. And the third type of problem with no audio or one-way audio is a thing called ALG, application layer gateways. So you can fix the NAT traversal using stun or return if it's a basic problem. If the connectivity between the addresses are okay, check if the firewall is not blocking the ports. To prevent problems with ALG, you have to configure the firewall. It's fairly common to have a MikroTik, Sonic Wall, sometimes Cisco blocking the address. One tip that I can give you is, for many operations, we just changed the source and destination ports out of the 5060 in the beginning of the operation. So do not use your phones on the 5060, do not use your termination on the 5060, and you can bypass all the ALGs on the network. It's fairly easy, and you don't need to go there and start configuring every single firewall on any bit, because this causes a lot of issues. So it's a way to, if you want to still support 5060, make sure you have another port. That's what we do. We have a big operation there for residential customers that spans the whole country, and we started from the beginning with a different port than 5060, and we experiment a lot less problems than in other cases. Using a back-to-back user agent for mitigation. This is another interesting thing. The problem of the termination is, okay, I have put a single termination and I caused a big problem in my provider, right? I don't want to do it again. What I can do, you can use an SBC, you can use a back-to-back user agent. So we have, in a back-to-back, you have the first call leg and the second call leg, and in proxy you have a single call leg. So if you put a back-to-back user agent between you and your terminations, right, you can, in the back-to-back will receive all the problems with the signaling, and will protect your proxy. You can have a problem on this specific back-to-back user agent, but you probably won't have a problem on your proxy cell, or proxy server, or user agent. So it's a good practice to use back-to-back user agents as a demarcation point for providers and save a lot of work. Okay, just that. So in summary, problems in SIP signaling affects licensing, billing, completed calls, disconnected calls, and out. Try to charge your customers per simultaneous calls with hanged calls, with 2,000 or 3,000 hanged calls. It's a challenge to support SIP on hundreds of different vendors. That's what we are doing right now. To get a stable and robust platform takes time, because it takes a lot of time to learn each of these cases. Wholesale operations are the most affected. I would say 90% of the problems in signaling are usually in wholesale platforms. In residential, where they have control of the client or the network, or corporate networks that SIP trunks for corporate networks, we rarely see the same path. We believe 80% of the problems are in the cases we have presented. These are the most common ones. That's it, so let's go for questions.
Who's got questions for Flavio?
Go ahead.
Anybody?
Oh, sorry. How do I do? Fraud calls. Fraud calls, we have a fraud prevention system. There are actually two ways that people are using to prevent fraud. The first one is they simply don't complete international calls. That's fairly common. If you want to do international call, go to your Skype or whatever. We won't complete your calls. You have to sign several forms to allow many of the providers to allow international. The other way we handle fraud is using a TFPS. It's a fraud prevention system. It uses. We started with blacklists, but what we are actually using are the behavioral call. So things such as if we have 5 calls from the same source to the same destination in less than 5 seconds, disconnect the call. If we have specific quotas for international calls during commercial days, during off hours. For off hours, we have different quotas. Like you're in a company. During the week, you can make five international calls per day, but during the weekend, you can make only one. Huh? Yeah, again, OpenSIPS has a built-in fraud model. We did something a little different, because we have these blacklists that are filled by honeypots. So usually, when they attack a honeypot, we put the addresses on the list. Very good.
Any other questions out there?
Yeah, it's the white one.
Okay.